Acids and bases. The common chemistry I've never been able to understand very easily, but I have been forced to do it at gunpoint and allowing me that it was a joke, a lie, a deception that most people have about acids and bases. Because acid doesn't mean it's going to kill you, even though it probably will. And bases don't make you miraculously immortal because they can kill you. Because bases are usually testing cleaning products as chloride or chlorine or whatever the hell you clean the floor with. It's up to you. I don't care. But how do you measure these things? Well, it's very easy to measure. We measure this with a number called pH, which I'll get into later. But the pH is on a scale. That scale goes from 1 to 10, or from red to brighter colors, or just more colorful colors, not necessarily brighter. These colors tell us the acidity or the baseness of an element, or the alkaline. Base can also be known as alkaline element. For example, if an element turns out to be red, if you do some chemical test on it, it'll be an acidic element. If you do purple or blue on another one, it'll be an alkaline element. Water is one of those few cases of neutrality, which means an element that's between 6 and 7 is a neutral element. And water tends to be neutral, even though some brands and companies try to be a little cheaper and make you die from acidity, but whatever. Now the question is, what is pH? pH is simply a measurement. It's a measurement to tell you how acidic or how alkaline an element is. For example, water can be neutral, around 6 or 7, while milk can be around 3 or 4. Meaning milk is acidic and water is neutral. Now the question is, what is a base? Well, you see, a base in chemistry are substances that aqueous solution release hydroxide or ions, are slippery to the touch, can taste bitter if it's an alkaline, or change the color of indicators. For example, turn red on blue paper. Like drug tests, which are fun and always been fun. And they can also react with acids to form salts, promote certain chemical reactions, and, for example, base catalysts, and accept protons instead of giving them out. Now, in the case of acids are a little more complicated as it can be used in different terms, but in chemistry, in the basic chemistry of acids and bases, an acid is a chemical substance that neutralizes alkalines, dissolves some metals, and turns them red. Typically, a corrosive or sour tasting little bit of this kind, which can be produced through health, as well as a base element, which is used to eliminate acidic elements as well, but that's a process that requires, neutrons, protons, and whatever. Another thing about acids are that strong acids and bases completely dissociate or ionize in solution, while weak acids and bases partially dissociate, ionize in solution, meaning they do have the same effect, but different consequences. Help. This really sucks. Okay. That was a lie. Deception. Agreed. Just like, I don't know. Wow. Like in the pH scale, where you can simply measure something with chemistry and other, elements, I think there's also a way to mathematically determine the pH of something. Saying, if you don't have a scale right in front of you or a chemical test, how do you determine an element being, acidic or base or even neutral? Well, the mathematical equation is a lot harder than it seems. I mean, easier, but it's. I don't know why you need to do this. This is just suffering for me. I need a vacation, but funny virus. Funny. For almost every part, the mathematical part that no one cares about and everyone will probably kill themselves trying to understand. Well, this is easy. It's simple. It's very simple. To calculate the pH of an aqueous solution, you need to know the concentration of the hydronium ion in moles per liter. Molarity, if you know what the hell that is. The pH is then calculated using the expression pH equal minus log, parenthesis, H3O plus. It's an example. For example, if you're using hydrogen and oxygen and you're combining that element, for example, see, what if I put pH equal minus log of hydrogen, the positive hydrogen parentheses, then I use minus log 1 times 10 minus 5, with polarity being the 10 minus 5, and pH equal 5. Well, you find your pH. It's 5. It's an acidic element. It's not that hard. And I don't understand it. This is not from Wikipedia, by the way. I wish it was. It's from chemistry procedures stuff, biographies and all that crap will be at the end of this thing that I've been forced to do at gunpoint, or at least, so I don't fail and become miserable for the rest of my life. That's funny. I know. I drink gel sanitizer. Anyway, that's the pH. How to calculate a pH, and how to calculate the pH of a solution. You have many ways to do it. Usually when it comes to base, there can be certain variations depending on the element, but for the most part, it's usually just calculating the molarity of that element with the hydrogen ion, which is molarity. and then using the expression used on a calculator. There is a manual way to do it on paper, but I don't know if I know that, and I don't know if I want to, and I don't know if you want to. I don't remember it. I don't know if it's even healthy for you. I can't. You also might ask, how do you calculate hydronium, the ion hydronium, or the hydronium ion concentration from pH? Well, I can't say it's simple, but it's a reverse mathematical operation employed to find the pH. It's the complete opposite. Example, what is the hydronium ion concentration in a solution that has a pH of 8.34? I'll put 8.34 equal minus logistic or log, parenthesis, H3O plus, parenthesis. This is an example of an element, a solution that has 8.34. Then I turn that previous element into a negative element while turning the minus log into a positive element, becoming a log. Just log, parenthesis, H3O, positive, parenthesis. Then the last element that I put on the equation will go into the front. It'll be equal to 10, which is from the logistic that we got, meaning 8.34 with the log, equal 4.57 times 10 minus the 9, m, which m is for the molarity of the element. On a calculator, calculate 10 minus negative 8.34, or inverse log, which is parenthesis minus 8.34, parenthesis. Now you say, oh, what if I want to calculate the pOH of a solution that you need to know the concentration of the hydrogen ion in mole per liter, molarity, the pOH is then calculated using the expression pOH equal minus log, parenthesis OH minus, or the minus being negative of the element. It's not to be actual symbol, it's a negative of that element, meaning it's above it. It's an expression. And the parenthesis again. Say, oh, well, what is an example? What is the pH of a solution that has a hydrogen ion concentration of 4.82 times 10 with the expression of negative 5 molars? Well, simple. We'll show here pOH equal minus log, parenthesis 4.82 times 10 minus 5, parenthesis equal negative of the parenthesis negative 4.32, parenthesis equal 4.32. Pretty much you're just taking the symbol away. But you're turning an element that says to have a negative number and turning it into a positive number. That way you can finally determine what is the pOH of that element, which is great now. And there are also many ways you can calculate pH and pOH, the relation between those two. You can also calculate pKa, which is a more complicated task, and that one, because this is more basic. So the basic is how do you calculate a pH and how do you calculate the molarity? Because in order to calculate the pH, you need the molarity. And if you find that molarity of an element, you can calculate the pH. There are various ways to find the molarity without the pH, but not going to get into that because I don't want to die right now. I don't want to be miserable. And I don't even know what I'm saying because I need help. This is suffering. This is legitimate suffering. Why am I forced to see this? Why am I forced to do this? I'm not forced to do it. That's my responsibility to do it. Yeah, that's great. Next, let me ask, why is calculating pH important? Well, I didn't mention that before, unless you're deaf or blind or something. pH is used to determine the acidity in the alkaline or the base of an element. For example, 6 or 7 being neutral, and in a liquid that's a consumable being the best for the human body, as it is not too acidic and it's not too base. Most cleaning products, for example, Clorox, if you consider that consumable, is a base element, meaning that element is used for cleaning and cleaning products. Yes, you have alkaline water that promotes to have 9.9 pH and blah, 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 but having too much of that water can actually affect you negatively. Or it can make you immortal, like some companies will say, but it's a bunch of bull. Then we have other elements like milk, which are more acidic, but the acidity is used for the stomach, the acids in your stomach. This is turned into an enemy list. Yes, this will have an existential crisis. You will not understand it by the end because it's also in English. Joke's on you. But the acidity of an element can be corrosive, meaning that element can be corrosive for your stomach, for example. Excessive amount of milk can be corrosive and can cause gas problems because the acidity of milk will react to the acids in your stomach and force you to want to die. But you won't die unless you do it excessively. That's your fault. At the end of the day, pH and bases are important for what they are and for what they try to be. Various mathematical calculations and various mathematical calculations. Okay, well, that's good. That's all. If anything else is missing, tell me, and I will jump off a cliff and probably not cease to exist. That's a joke, but I lie in it.